Hi there. So we're going to start off today with constant acceleration. I'm going to go through one question on here, give you another one to practice. You can then upload to me how you've got on with that, and if you need any more practice, the revision guide is a very good place to go to. Pages 150 and 151 would be a really good start. So here's our question. Pause the video, see how far you get, just in case you're not sure. Mechanics, all they give you in the functions booklet is the Suvat equations, and we are going to be using those. So the first thing to do is always to make a little sketch of what's going on. So we've got our pebble that's being thrown up, and then it's going to hit the ground at some point, and the ground is 32 meters below. We know that u, the starting velocity, is 21 meters per second, and we want to know the speed at which it strikes the ground. So at that point we can say that if the acceleration is negative 9.8 meters per second, then we could call this negative 32, the distance down to here, couldn't we? So s is negative 32, and there's more than one way you can get there, but I think the quickest one would be to use v squared equals u squared plus 2as, because that'll tell us our final velocity straight away. Putting in 21 meters squared and 2as to be 2 times negative 9.8 times negative 32, which will get rid of our negative there, won't it? And then we're going to have the square root of all that to find v, which should give you 32.68 something, which is 32.7 meters per second to 3 significant figures. Okay, so now pause it and have a go at part B. The total time for which the pebble is more than 40 meters above the ground. So that means if I was to do it 40 meters above the ground will be 8 meters above where it's gone. So we want to know the time between those two things there. So if I use Suvat, I can find a quadratic equation to give me both times that it's 8 meters above it, positive 8. So that would give me s is equal to ut plus a half at squared, and if we start popping in what we know about that, we know that it's 8, we know that the starting velocity is 21, so that's 21t, and then we know that it's a half times minus 9.8, so it's negative 4.9 t squared. Now if I rearrange that to give me 4.9 t squared, take 21t plus 8 equals 0, I've got more than one way I can do it. I could use the quadratic formula, or using the calculators, we could just go to the equation solver, the polynomial, and pop in 4.9, negative 21 and 8, and execute that, and we get 3.863 and 0.4226. So the time is 3.863, sorry, 863 and 0.4226. So the time above 40 meters is going to be 3.863, take 0.4226, which is 3.44 to 3 significant figures out seconds, isn't it? And now just time to have a pause again and have a crack at sketching your velocity time graph for the motion of the pebble from the instant it's projected to the instant it hits the ground, showing the values of t at points where the graph intercepts the horizontal axis. Right, so we are going to be having, remember that velocity is a vector, so what's happening at the beginning? It is 21 meters per second, so velocity in meters per second, and then it's going to be falling at a constant rate until it gets to 0, but then it's going to continue to be falling. Actually, it'll be going faster, but it'll be going faster in a negative direction. So for that reason, we need to find a ruler, and we're going to be wanting a straight line going through, and it'll be going until the point at which it gets to, oh, I've gone a bit far there, haven't I? But we're going to be going to the point at which it gets to negative 32.7, because that's when it hits the ground. And we're going to need to know two things. We're going to need to know the time at which the velocity is 0, and we're going to need to know that time there. Now, my favourite way of working out when the velocity is 0 has to be halfway between the two times at which the distance is 0. So we've got the pebble going up, then it's going to go down again. Distance is 0 there, because it's a quadratic curve or parabola. Halfway across there, the time will be 0. So we can say, using suvat and s equals ut plus a half at squared, we can say the distance is going to be 0 equals 21t minus a half of 9.8 is 4.9 t squared. Then we can just say t is equal to 21 minus 4.9 t equals 0. So one time is at 0, and the other time is going to be when add 4.9t is going to equal 21, so t will be 21 over 4.9. So if we do that time and then halve it, because the first time was 0, we should get there, and that should give you that should give you 2.14 to 3 significant figures. So that's 2.14 there, and then all we need to know is the time when it hits the ground. And I think the neatest way of doing that is using s equals a half u plus v t, because we know that the ground is negative 32, then we've got a half, we know the initial speed is 21, we've worked out that the final velocity is 32.7, so our time is just going to be negative 32 over a half, 21 take 32.7 is going to be the time. So whack that into the calculator and you should get, what do I get, 5.9 5.47 seconds. So we can put 5.47 just there. And that is that completed. Okay, great. So hopefully that's all made sense. If it hasn't, get in contact. Now I'd like you to have a go at this question here, which you can either do just by pausing it here, or if you want to turn to the book and find the answer there as well, that's great. And then email me that to show how you've got on with that. Great stuff. Thank you very much, folks.